So this is going to be the last day of admin of code for this year. And I thought that I would do a quick 1-minute recap of every puzzle from this year and how I solved it. And we will go through kind of how one might expect to solve each of these puzzles. So let's go ahead and go to day number 1. So in day number 1, it was a problem about about doing some simple math to a list of numbers. And then after that, doing some additional math to recursively, when you add a number, to also add a third of it and a third of it again until it diminishes to nothing. And the solution that I picked was basically to do a straightforward, convert each number in the list to an integer, and then to do the math that's required, add to the cumulative sum, and then to repeatedly carry out the operation until the amount of additional fuel added at each step was 0. So, day 1 is always kind of the teaser problem that explains, here's what you ought to start doing and start writing libraries for. Okay, on to day number 2. So in day number 2, we first encountered the int code computer. And the int code computer becomes the building block of a lot of the rest of the puzzles for this year. And they strongly hint that you're going to need it because they say, hey, keep it around. Keep it nearby during this mission. You're probably going to use it again. So basically, they want to verify that your int code computer is working correctly and that you have the ability to increment a program counter and that you have the ability to actually make your code execute things in sequence in order to make some simple values add and sum to the correct value. So the approach that I took here looks something like this. The approach that I took basically looks like a combination of two things. It's a combination of a simple input reader and then to first feed in 1202 and then later feed in every combination of 10,000 different possibilities to see whether I got the expected value when the tape finishes processing. And as far as this int code module, if I jump to int code, I can't show you exactly what it looks like. At the moment that I wrote it on day 2, but it's pretty darn similar. Basically, something to read the input and to split the sequence of integral values. And then we also needed something to be able to process each different opcode with each different instruction length, although initially to start with, we were given instruction lengths of 4. Every instruction was 4 different, had the instruction opcode, and then two arguments and output parameter. And then we were basically asked, add, multiply, pretty straightforward, add, multiply, and then 99, which is terminate program. So that is day number 2. So if we go on to day number 3, for day number 3, you're basically asked to simulate wires folding out from the origin. So this is kind of the first puzzle in this year where we were required to start doing basically key value paired maps where keys are coordinate pairs. So fortunately, that is pretty straightforward. So let me show you what I did for that day. So for day 3, I basically instantiated the coordinate type. In Golang, X, when you define a struct made up of symbol values like integers, you can use it as a map key. And therefore, that makes it pretty straightforward to just say, evaluate the set of instructions, move the pointer in the direction stated, and store the places that we've already traversed. So over here, I basically have a tracker that computes both how far away from the origin is it, as well as how many steps it took me to get there. And that's basically what we need to do day number 3. So let's move on to day number 4. For day number 4, we need to, again, this doesn't involve the int code computer. So it's basically trying to come up with a sequence of numbers that meet a set of criteria. And the key important thing is digits never decrease. It means that you don't have to search arbitrarily many digits. You have to, make the choice of how far you increment by each time. Yes?
I haven't done all these, right?
Oh, crud. Am I spoiling you? Okay.
Give me like 30 seconds and I can go downstairs.
Okay. You're working on day number 5, yes?
Yeah.
Okay. I promise I will not spoil past day number 5 until you're downstairs.
All right, thank you.
Okay. So for the solution to day number 4, what we wind up needing to do looks something like this. Basically, we just check whether each possible thing is meets the criteria. So if we have a repeat, then we mark it as a repeat. If we have an exact double, then we mark it as an exact double, and we check to make sure that the digits are in increasing order. And and that's how you do day number 4. So it's a pretty simple iteration, and did you correctly implement the criterion that they're asking for? So now on to day number 5, which I will describe the problem of, but not the solution of, because a person that I live with and love dearly is still working on it. So we have to add 2 new instructions to the encode computer for day number 5. And specifically, it starts to add I/O as a possible operation, where you can add, not just supply values in memory at the beginning of the program, but also to supply inputs and outputs as you go along. So it ends up being useful. And secondly, that it's not just taking literal values, but also, but you can have literal values, which are called immediates, and you can have positions, which we did before, which are basically reading the value on the tape at position number X or position number Y or position number Z. And this wording caught me by surprise later on. Parameters that an instruction writes to will never be in immediate mode. Never be in immediate mode does not translate into always going to be in position mode, and that was something that that caught me by surprise later on. So we run a bunch of diagnostics, and then we actually finally become fully Turing complete. So jump if false, jump if true, less than equals, and this is the case where. This is the case where I think that my program initially was outputting a value that I wasn't expecting. It turned out to be the opcode that was broken. Haha, very funny. But it took me a while to catch up on that. So I'm not going to show you day 5's code, actually, because I showed it to you earlier when I was showing you day 2. It's basically kind of modularly adding pieces on. And that's how we approach day number 5, is just making sure that your encode computer is now fully Turing complete. So if we go on to day number 6, and let me make sure, in fact, that there are no weird surprises in day 5. I guess, yeah, no, there's no weird surprises in day number 5. Okay. So day number 6. In day number 6, you're asked to compute, given a list of varying things that supposedly orbit each other, to kind of construct the map and to figure out how many things directly and indirectly orbit each other. So that is basically running a digest and figuring out, okay, if I have one node here, then that's worth 1. If I have this node here, then it's both orbiting the thing it's immediately orbiting plus the thing at the center of mass and so forth. So it's basically propagating from center of mass on outwards. And afterwards, you have to compute a path on that. And that's, how did I actually solve that? Let's have a look at that. So for day number 6, okay, I'm not spoiling my housemate. Good. So for day number 6, as I was saying, we basically parse it and set up a map from string values to string values to get the parents, and also do maps from strings to ints to compute distances. And then after that, the trick here is you start from you and from Santa, and you find where you have a common parent. And as soon as you find a common parent, then you know that you have to get to the common parent from both ends, and then you know that you've satisfied the criteria. Okay, so that's day number 6. Day number 7 in your lightning tour of Advent of Code 2019 is the amplifier. The amplifier is the first real non-trivial use of the encode computer. And it also is non-trivial use of the inputs and outputs. So it requires you to try a variety of different combinations of phase setting sequences, and also, and you have to feed these things through in order. So you can kind of try essentially kind of like 5 factorial different combinations. And what we wind up doing there is pretty much what you would expect on the tin, except for we have to very specifically wire each of these things together. So phases 5, 6, 7, 8, 9. We basically have to do something that says, hey, by the way, the input of part X goes to the output of part Y, and so forth. And this actually took me the longest of all of this. The reason it took me the longest is that I had forgotten how to scramble and do permutations. So that's remedial computer science for me. But, good opportunity to just check it. Turns out there's a base case and there's a recursion, and you can make it work. For part B, now you have to make it infinitely loop. And in order to make it infinitely loop, we use the phase settings from 5 to 9 used exactly once, so you can still permute it. And we wind up trying repeatedly the running the amplifier until sending and receiving signals until it halts. So the other interesting piece of this is doing the detection of when you are done, then you need to check the highest output values, especially the output at the end, obviously. Okay. So day number 8, moving right along. I have 20 minutes to cover 15 puzzles. Let's go. Space image format basically is asking you to evaluate layers to find the layer that has something. And then after that, you wind up stacking things together and making sure that everything lines up correctly. And what we wind up doing there is something like this. So I defined in advance what the input and output sizes are because it makes it easier to store. And then you can actually basically iterate over each of these sheet layers and try each layer one at a time, see whether there's a value, and if so, print it, and if not, then you need to go back into the next layer and so forth. Okay, day number 9. So for day number 9, we are running encode computers, and here the various modes come in handy. It's similar to position mode, except for it's relative to the it's relative to the relative base. So this lets us start doing things involving using the encode buffer as a stack and having functions that run and operate on values relative to a stack. This lets Eric actually do tricks to encode in the future using function calls, and we wind up providing it with the correct input once the diagnostics are complete. So this is, again, a place that tripped me up. So let's take a quick look at that to show you what that actually looks like, because I think that does bear a little bit of explaining. So if we are in relative mode, then we need to change the offset by the base. And then we need to make sure, this is where I had to amend things, because it turns out that before I was literally passing the pointer to update, and now I needed to actually specify which offset to adjust instead. And that works because you're not allowed to, set the number 10 to some other number. That yields logic errors real fast. Okay, day number 10. So this is the first day with the really cool visualizations that other people did. Basically, to find what has the fewest things with no greatest with the, how do I explain this? That reduced the most distinct unique fractional ratios of x to y. And then afterwards to vaporize the asteroids in arctangent order. So this honestly took me a fairly long time, mainly because in this particular problem, I wound up having to fudge around by hand for a bit before I realized that it was arctangent 2, and also to realize that it was the column value is the x value, the y value is the row value, or like I somehow got my coordinate system messed up and had to align it. Once I did that, it was relatively simple to normalize it by arctangent. And then to destroy asteroids one at a time, which is a state machine that you basically have to keep track of. Okay, day number 11. In day number 11, this was the joke that took me a while to get. This is a EVE Online joke. Whoop, whoop. It's the sound of the space police, aka Concord, who blow you up if you don't, if you violate the rules. So we have to run the whole painting robot. It has two modes, one that generates a fractal and one that prints out a piece of text, depending upon the initial value. And this basically involves you being able to interact with the Unicode computer and basically take a repeated stream of outputs and render it. So here again, a map of coordinates winds up coming in handy. So basically, we have to feed the encode computer at each point what the value is, either 1 or 0, on the square that it's currently standing. And then it tells us whether or not to repaint it. We have to keep track of what direction it's pointing. And then after that, we basically wait for it to produce something that vaguely looks like a rectangle for part 2. Okay. On to day number 12. On day number 12, this one was super infuriating to me because it had a gimmick to it. So please close your ears for 10 seconds if you don't want to be spoiled. The other ones I feel are relatively spoiler-free in that I feel they're straightforward and have no gimmicks. This one had a gimmick, which is that you're simulating 4 objects in 3 different dimensions. And it turns out that continuing to spoiler, the 4 objects in 3 different dimensions, each dimension is independent, and each of the 3 dimensions is on a cycle, and therefore, in order to get to a steady state that exactly matches the previous state, you need the greatest common denominator of all 3 different axes, and that's what you have to do. I just missed it. So that was infuriating and took me forever, and I'm kind of mad after the fact, but this is what Ask Your Spouse is for. So my spouse gave me a minor hint and asked me, hey, what does each coordinate depend upon? So that's what I wound up doing, is basically testing for each axis, how many cycles does it take to repeat, and then I have some GCD computation math here. So that's how you approach day number 12. Day number 13. Yeah, we'll get there before midnight. So you run the arcade cabinet. It's the program Pong. Some people reverse engineered this one. The way that I approached this one is I wound up actually simulating it, and I built a perfect player for it. So it looks like this. Essentially, it says, run the encode computer, and then, there's a method to be able to print out the encode, the current state of the board. And then you basically feed it it prints out a set of X and Y coordinates to paint. And when you're actually playing on behalf of the player, we basically check, are we to the left or right of where the ball is going to land? And then we just go ahead and reflect the ball out perfectly. And then it breaks all the blocks flawlessly. It's an interesting thing to watch. I encourage looking at someone else's more sophisticated visualization. I did not do a sophisticated visualization. Okay. Now we are talking about day number 14. Day number 14 involves repeatedly running a set of recipes and trying to produce as much fuel as possible, or telling you how much ore you need in order to produce a given amount of fuel. So the way that we approach this is essentially we can repeatedly execute some rules, keeping track of how much of the leftovers do we have after computing the minimum amount required to produce a certain amount of fuel. And in order to figure out how much you can produce with a certain amount of ore, basically you need to repeatedly request more needed resources, or at least that's how I approached it. And I essentially bisected it rather than trying to figure out which recipes to run in which order backwards. It was just easier for me that way. Okay, day 15. On day 15, we lost our oxygen supply, but the repair droid can move us around, but we don't know what the maze looks like. The droid has to map out the maze before it can tell us. So the way that we handle this is, and also there's a little twist, which is at the end, we need to calculate how long it takes to fill the entire maze, and it turns out that a random walk is pretty good at the start to at least figure out where the oxygen can is and figure out how many steps it takes to get there. But what it won't tell you is how big the maze is in total. So we wind up having to write something that basically tries to explore the maze as much as possible until it locates no more dead ends to explore. So this is really our first exposure in this set of puzzles to the breadth first search and to the A-star search. I did not use an A-star search here with the heuristic. I just ran a straightforward breadth first search. And basically you kind of spread outwards from the origin, searching various points and prioritizing them, and you eventually construct a map of the entire base. And then you can calculate how the oxygen would flow outwards from the square that you're starting. Okay. On day 16, we have the FFT problem. The FFT problem is another gimmicky problem. The first part is not that is not that challenging in that you basically have to repeatedly compute the same algorithm. But that's kind of this interesting trick, right? Where it's encouraging you to write the algorithm, and then in part, so it encourages you to actually evaluate the algorithm fully at each step. But then for part B, and shut your ears if you don't want a giant spoiler, in part B, what winds up happening is we wind up being asked for a very clever value. We wind up being asked for a 8-digit message that starts at more than 50% through the final output list. And it turns out that while computing the first half is roughly I think n to the fourth, or maybe even worse complexity. It is essentially linear complexity to compute the latter half. So you have to notice that, hey, we only are computing the latter half for the second part of day number 16, and that makes it possible. There's a little bit of tricksy math, and I've kind of drawn it out here, where you're repeatedly adding 1 to the end, and therefore you just add digits modulo 10, and you have it good enough. Okay, day number 17. Day number 17 is the scaffold robot. This one took me way longer than it should have. I tried to compute the paths manually by hand. I tried to compute the paths automatically, and eventually I wound up finding something that works. It's kind of a optimization problem where there are a bunch of different valid possibilities to do it slightly incorrectly, but there's only one possibility to do it correctly. So your first task is obviously to keep track of the passable map. What I wound up doing is I wrote an automatic solver that would generate the full list of instructions to turn left or right whenever it hits a dead end that it can only turn left or right at. And then I expressed it as a sequence of, if it was left 7, I would do left 1, 1, 1, 1, 1, 1. That way I could find different subsections that didn't actually wind up being necessary. And I can't believe I didn't find this by hand. But what I wound up doing was basically checking that each of the 4 patterns I was generating were, in fact, the complete pattern when used in some sequence. And that's how I did day 17. Day number 18. Get sucked in by a tractor beam. This is the infamous key puzzle. So the key puzzle, various people have various tactics for approaching this. Fundamentally, it is a set of nested searches, in that you're attempting to search the space of all possible sequences to acquire the keys that's valid, and you're trying to assess how many steps it will take you at minimum to acquire those set of keys in that order. And then after that, they add the complication that there are 4 different players, each of which is confined to a separate part of the grid. So I found this to require some knowledge of both breadth first search as well as A-star search. So basically, I constructed a state object that encapsulates the list of keys I've collected and what order I collected them in. And then what I wind up doing is I wind up saying, if there are 2 different paths to get to the same set of keys collected, it doesn't matter which order you collected them on, as long as you wind up on the same key at the end. And then we can calculate how long it takes to collect all of the keys. And then it actually turns out to run faster because you're more constrained in how far you can roam in the maze to acquire any given particular set of keys for the part B. Day number 19. We wind up having a tractor beam. And the tractor beam is somewhat pseudo-randomly generated. So it means that there's no formula for this. But the one trick that you have to notice is you have to notice that the beam always grows or shrinks by 1 or 2 at any given step. So if you keep track of that, then essentially you can encode, instead of encoding a full n by n matrix, what you can wind up doing instead is encoding ranges to say that on line X, the beam starts at x position at this x position, ends at this x position. And then for the next row, you only have to check plus or minus 2 to find where the next boundary is between in the beam and out of the beam. And then when you're computing what the what the first 100 by 100 square is, you basically go look at what's the first row that has at least 100 wide, and then does it overlap by at least 100 with the beam 100 squares below? And if it does, then that's your answer, and that's how I solved day 19. Day number 20. Day number 20 is another maze problem. So hopefully you wrote an A-star search and can just reuse the A-star search. The caveat is now there are portals between different locations, so you can no longer use a straightforward heuristic of saying that the linear distance from start to end is the minimum distance I might have to travel. So there may be a magical portal that takes you closer. And then the twist added is that it's recursive. That when you go through an inner wall, you wind up at a outer wall of a descendant copy of the maze and vice versa. So the way that we solve this is essentially doing a breadth first maze search in which there is both an x and a y coordinate as well as a z coordinate. And there's a little bit of tricky parsing math to create each of the entrances and pair them to each other. And in particular, I got wrong that I got my z offsets inverted because I forgot which direction the maze went. So that was day number 20. Day 21. Day 21 was executing a spring droid with a pseudocode language. I'm not going to spoil it, aside from saying, think about, you have to think about in which cases it's safe for the droid to jump and in which cases it's not safe for the droid to jump. And what's really cool is that this is being parsed by an actual Intcode computer. So if you had a working Intcode computer, great. If you didn't, then it really blew up in your face. Day 22, infamous day 22. I just did a review of this. I'm going to do a bad job summarizing in 1 minute. Essentially, day 22 was about modular arithmetic, combinatorics, and a to the power of b mod m, and doing reductions thereof. Because it turns out that you can't compute x to the y power by hand, where the y power is like something literally like this, or where the modulus is a number like that. You can't compute it by hand. You have to get the computers to help you with the smart algorithms that we have for modular arithmetic. I'm kind of bad at explaining it, so I'm not going to right now. Day 23. Day 23 was a problem about parallel I/O. My solution to day 23 is ugly and hacky, and I don't really like it. But this is what I did for day 23. Essentially, I stood up 50 of these networking devices, each of which gets the ID number that it's supposed to run. And then I set up 50 forwarders that forward the outputs, that route the outputs into the inputs. And then there's this interesting halting problem-like thing where if you think that it's all gone quiet, then you need to, at the right time, send a signal to the 0th one to poke it to wake back up again. So that's what I wound up doing just after a bunch of trial and error, like saying like, hey, wait 20 milliseconds between wake ups, like don't double wake it, which was that was my downfall earlier, and I acknowledge it, and now I understand what I did wrong. And finally, in this whirlwind tour, we land on Eris, having passed Pluto and Halley's Comet earlier. So this is the game of life carried out initially on a 5x5 board, and then the game of life carried out on a recursive board. Yes, you heard that right, a recursive game of life board. So the way that we solve this is similar to the way that we solved the maze, in that we have to maintain a separate Z coordinate. So we wind up setting up the rules, right? Saying, hey, is the bug alive in this grid? How many bugs are alive, and making sure that we do the state machine correctly. And then for the more complicated 3D case, if we're evaluating an innie or an outie, then we wind up needing to look at the inner or outer copy and initializing it to all falses if it's not yet initialized. So that is where we stand. Thank you, Eric, for the good wishes. I appreciate it. So we are at 1 minute to puzzle unlock. So I think that I managed to whirlwind recap Advent of Code days 1 through 24. Of those days, I think Pong was probably my favorite day. But I did like most of the days, except for the really frustrating gimmick days with the FFT and with the modular arithmetic. So, time to take a sip of water, breathe, because the puzzle is about to start. I'm not going to set any speed records. I'm just here to finish it in the first like half hour, something like that, and then I'll go to bed. Okay. So, make sure my terminal's set up. Yeah, my terminal's set up. That's good. 30 seconds to puzzle unlock. So, reading comprehension. So usually the convention here is for day number 25, part A is usually something that's relatively light, and then part B is do you complete all 49 other stars? So hopefully convention holds, and it's a nice sweet dessert to top off Advent of Code, the kind of cherry on the sundae. We'll find out. 2, 1, 0. Oh no, we found Santa's ship, but the temperature is minus 40 degrees. There's a life signal. We have anticode on an ASCII computer. Take an item, drop item. Oh God. This is literally a. Okay, this looks like a. I'm going to make this thing take manual inputs while I learn the puzzle. So let's grab an input and let us tab over here and save it. Making sure to name it .input and not .go. Today's puzzle is, holy crud, this is an 18 kilobyte puzzle. Eric, you've outdone yourself. Is this an encode day? Great. Actually, that's a bad encode day to copy. Let's copy day 21. Okay, so we're going to take in our day 25. And we're going to do our standard thing. Okay, so we need to prompt for user input here. So we need to repeatedly prompt for user input and then execute the user input. That's what we need to do. So let us. I've forgotten how to prompt for user input. Read std in going. I literally haven't had to do this all year long. Read full sentences. Okay, great, that's fine. Port buffio. Okay, for range buffio new rear OS standard in. Okay. So we'll evaluate our environment by scratch for now. Yeah, that sounds correct. Read in each character. Is the new line included? Oh, I see. That needs to. Okay, let's do it this way. Okay. Reader read string. Looking for /n to delimit it. Okay. Fair enough. So let's see how this works. Uh, 43. Oh, it's fine. Yep, that is exactly the kind of puzzle this is. And Eric, you have fucking outdone yourself. I find this amazing. Thank you. Thank you so much, Eric. Oh. I am... Oh, I see. It's double printing the /n. Okay. So I don't need to do this. Okay. 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 Well, I better take all the things if I can. I may need them later. Okay. Great. So now we go west. The beds are all too small. That's fine. What's dehydrated water? How did I get here? I got here by going west, so let's go south. Have a bunch of items. This is good. Okay, so I've gone east. I need to go east again. Oh, God. Very funny. Okay, do not take the infinite loop. Lesson learned. Okay. Ideally, I would like to save the state of the program so I don't wind up... Oh, God. I'm also wishing that I'd recorded which commands that I ran, but that's fine. I can retrace. I have a pretty good spatial memory. North, candy cane, east, west, south, south, take fuel cell, south, take manifold, north, north, west, mutex, north, west, east, south, 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 take coin, east. Not taking that. Not taking that. North, east, north, north, I think on, great. Take photons. Oh no, been eaten by a grue. Okay. Do not take the photons. So I'm starting to take a file of notes here. Do not take. Okay, I'm starting to understand this. Do not take photons. Do not take infinite loop. So I think I understand the point of this. So assuming this maze is very, very huge, so I need to automatically explore this. Human player parent. Okay. In fact, all of this is part A, really. All of this is part A. So, really what I need to do is, this does need to run inside of a function, but instead of printing the output, or in addition to printing the output, I need to, okay, if, actually Go formatter will take care of that. If not, if manual, then execute this. Otherwise, I need to run the Explorer. So when we explore, always pick up items unless on block list. And eventually we may have to figure out how to discard items in order to meet the criteria that we need, but that's fine. Okay. Stop if we encounter unexpected problems. Actually, we should automatically control it anyways. It's just that there's an option for a human to intervene if we encounter. Okay, great. Okay. Okay. I'm going to Chan string it. And input Chan string. Okay. So now I have a sense of how this works. Let's see. So do not take the photons and do not take the, is it literally called the infinite loop? Oh God. Yeah, it's called infinite loop. God, this day is so fun. Thank you, Eric. Oh my God, thank you. This is making my day. Okay. Let's not call this output. Let's call this lines. Let's buffer up to 50 lines for now. That's fine. So call this C because it's actually literally a character. If C is the new line character, then create a new line. Okay. Otherwise, probably goofed my number of braces somewhere. Or did I goof my number of braces? Somewhere down there. Okay, I think I goofed it down here. Oh, I goofed it in here actually. Okay. 169. Okay. Need one more of these, and then we'll find out what Go thinks that I meant to do. Yeah. Oh, if manual, then we do this. Otherwise, we don't. Okay. There we go. Okay. Actually, that doesn't need that. That can do variable capture from the outside. Actually, all of this can do variable capture from the outside, so I'm less worried about it. Okay. All right. So save here. Okay. Great. All right. Then continue. All right. I have an empty line, I continue. What are the possible kinds of lines? I get the name of the room. I get the items, and then I get the command. So it looks something like this. Let's see. Just want to enumerate this. Okay. Let's have a look at this. So just want to keep track of, for now, what rooms I know exist. I might need this later or not. Okay. So okay. Actually, let's do it this way. Okay. Location will be yeah, that seems right. Okay. That deals with that. All right, let's see. This is actually a bunch of cases. That's fine. Okay. Let's do it this way. List. Okay. All right. Okay. All right. So okay. Let's see. It's passable if there's a room name assigned. That's what I'm going to go with. That seems fine. Cool. Okay. 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 All right. All right. All right. Doors. Okay. All right. That's one of these. Okay. Once we've left an area, we should reset the items. All right. God, this is so fun. Okay. So all right. What happens if I pick up an item? You take the take and then asks for me for a next command. Okay. Okay. Need to feed to the driver. If I'm not allowed to pick it up, then don't pick it up. I thought for a second about manually exploring the maze, and then I realized that with a 17 kilobyte program, Eric could have done all kinds of nasty shit. So I'm instead going to do this the safer way, rather than investing a ton of time into a manual solution. Okay. This is going to take me more than half an hour, but I am more than happy to spend half an hour on this. This is so fun. Okay. So Okay. How do I truncate this to 0? Slice to 0. Remove all elements, keep all the memory, slice it to 0 length. Okay. So this is keep forgetting that this syntax exists and I don't need to manually initialize things like I used to. Okay. All right, so should do it. All right. It's outbound. Okay. I suspect Eric has left one of these for us as well. Okay. Are these named uppercase or lowercase? Lowercase. Northeast, southwest so far. North, east, southwest. Okay. Okay. Let's use Cartesian coordinates. So north is going to be y plus 1. East is going to be x plus 1. South is going to be y minus 1. west is going to be x minus 1. Okay. If I've been there before, unless we know we need to backtrack. And it kind of is amazing that it's taken me this long to write like what my brain instantaneously parsed and understood in 5 seconds. I find this hilarious. Okay, so let's just first of all make sure all of this compiles. Oh, of course. Line 114. It's just that, line 122. Range. Function must be invoked in Go statement. That's fine. I think that should do it. Okay, good. How do I handle the backtracking versus not backtracking? So right now I have something that will pick up, that knows how to go places. So if I carry out the command, so we need to feed the driver Okay. I think that should work. Okay. All right. So now, need to know how to get from point A to point B. So this is very similar to day number 15, where I had an n known maze structure. Yeah. How did I know which rooms I wanted to visit? What was calling path? Ah. Okay, so I need to include the code from day 15 here. And take out the stuff that's not relevant. Specifically, I don't need the oxygen fill. So let's take out the oxygen fill. And let's take out the might need to print the maze. That seems like a good idea. Okay. So let's do this. Print the first character of the room name. Otherwise, print nothing. Okay, that seems to be reasonable. Yeah, almost if. Okay. So don't need any of this code here because I've duplicated it elsewhere. Do need this though. I have my passable map. I have my location. Okay. So I need to simultaneously do a DFS. So next direction. Let's have my current location. Have my unexplored. Okay, and I even know what is on that list. Okay, yep. That's correct. So this worker here is going to be keeping track of okay. Q. Oh, but that's now going to require locking, so I'd better actually just have a function. New room. Okay. 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 All right. This function needs to repeatedly run. How do I pass back the intermediate results, though? That's the challenge. Okay. So I need to keep track of what my current destination is. Okay, so if I have reached my current destination, then I know that I need to search for, then I know I need to pick a new destination to work on. Otherwise, I know that I am en route to my destination. And I'm fine. Okay. Okay, so this is fine. If That feels better. It sucks to be repeating this work, but I'll figure out a way to memorize it. In fact, that means that I don't need this mutex after all. But on the other hand, it doesn't slow me down much, and it can't hurt for later, so I'm going to continue doing it. Okay. This needs to know about the set of places I can go, which is rooms. Okay. Okay. Path from loc. Okay. Yeah, if I get asked, yeah, okay, that's correct. Okay. All right. Yeah, I feel better about this. Okay. Okay. Path from location q.dst rooms. Okay. Right. Okay. Now how do I handle this? I need to take the lock at the start of the function. So this seems cleaner. Okay, so if we've explored the whole maze, then there is no further work to do. Okay. That should do it. So the path function needs to take the rooms, and that takes a string, and turns a okay. No. This literally needs to run the BFS. It's not even called path, it's just called BFS. Okay. Source, destination, rooms, and that returns a direction. I think. Yeah, that'll return a direction. But in order to improve cacheability, I can even predict what I'll need to do to reach there. Okay, so that's fine. So initially, we'll set this to do this. But in practice, okay. That seems fine. That seems correct. Oh, I see. Oh, that's why I did it that way. You know what? I need to preserve this flexibility just in case there are weird directions in here. Okay, this needs a move function. I did define chord somewhere, did I not? Please tell me I defined chord. Fine. Okay. I need sync. Okay. Yeah, it is full all the way, turtles all the way down. Okay. Okay, 57's wrong. Oh, that's fine. Driver. 6. Okay. I need math. I need okay. Okay. That gets past Q and location and rooms. You just need to echo this back so I know what my program is doing. Okay. 227, that's not in a loop. Yep, that's correct. Oh, if I am short circuiting, then I need to rerun this. Until I have a room that's okay to explore. Okay, that goes inside of here. Okay. And 232, this is now unexplored becomes q.list. Okay. Whittling down on this. Oh, whoops. Do it. Passable is now rooms. 35. Let's see. We know the room exists. When we add it to the queue, yeah, that's fine. That's allowable. that's fine. Shortest, so that's actually an int. Okay, yeah, that's correct. Oh no, this should not be an int, this should be a string. Oh. Getting there. Distances, oh, I guess I don't care about that anymore. That's now done elsewhere. Okay. Let's see how we do. So it doesn't seem to perceive that north, south, and west are being added. Okay, great. Let's explore. Okay, so now, why is that? Oh, because I haven't initialized this. I should have parsed this correctly. So make sure that I'm seeing these first of all. Okay, so I do see the north line. Is my bad assumption that this maze is not explorable by hand? Because if so, I've done the most overwrought thing ever. I am happy to take a brief suggestion. That is not my bad assumption. Let me phrase it this way. Is this something that I would discover by running my program, or is this a bug in my program? If it's a bug in my program, I'd like to know. If it's an assumption I haven't discovered yet, I'd rather... that the maze does not actually have up, down, left, right, straightforward up, down, left, right coordinates. Okay, that is not surprising. That was one of the tricksy things I was suspecting would happen. And so it goes, which is fine. Right now I can't even get this working, but yeah, the way that I would solve that is to keep track of between each pair of doors, between each pair of rooms, what the appropriate instruction is to get to that room, rather than keeping a strict coordinate system. Okay, we'll get to that in a second because right now I've got something that's just completely hosed. Items in outbound are not getting cleared. This is wrong, and that's fine. I'll fix that in a second. Did I do wrong here? Parsing correctly. Okay, so this needs to be ripped out. All right. Right now, I'm not even doing this. So that should be working. So I've added the room to the room. Oh. I see my problem. This needs to be a mutable queue. And really, this should be a property of the queue. There we go. Okay. So yeah, I'll fix this in a second. Start from my source. So I want to find out why I'm going wrong here. So I check 0, 0, or at least my origin room. So now that I know that this assumption is wrong, I will rip out my print maze function. That's useless. This should still work for the small set of things. Even I should be able to at least move to one room. So that's clearly not working. This real fast. I'm no longer using math. It's fine. No longer have print maze. Ah. Oh. That's my problem. And I'll have to rip this out anyways, but... Okay. Good. Wonderful. Okay, so as soon as I get the "you can't go that way" message, I know that something has gone dramatically wrong. And I know I just need to bail out. In fact, let's always allow manual mode. Let's just always allow manual intervention. Okay. Where's my... Oh, I see. That needs to run inside of the go function. Ah, that's better. Okay. So I automatically go north. I take the candy cane. The valid directions are east and south. I've added the directions east and south. Why is it trying to go north now? This should still work. This is still in a Cartesian coordinate system. I will fix this later, just not now. So check this. Oh, I know what I'm missing here. Okay, now is the time to rip this out. Now that I know that I have this working. So I have a list of rooms, and then I have the directions I need to go in order to reach other rooms. Okay, that makes sense. How do I encode this? You know what? Let's do this for now. Again, temporary, very temporarily. Okay. This is now working better. Been been able to take all of these items, which is good. So now I encounter the thing that Eric was going to tell me, which is that I haven't yet. Okay. Still is throwing me a little bit, but okay. Okay. I've been to a room. I know the room exists. Yes, I have to be able to index the room's string name to exits. And the exits is okay, so let's redo this. I'm going to actually before I do this, I'm going to commit my code so that I have it. Because I don't want to blow all of this away by accident. Oh, is that going to work? Yeah, that will. Great. Okay. So much for promising my partner that I'd be in bed by 1. Normally it's a relatively formulaic puzzle, but this time it's not. Okay, so work out the coordinate. All right, so okay. Okay. That's fine. All right, so doing this better now. Okay, that's actually fine. That doesn't have to be fast to search. Okay, so that should work better. Now, don't need to copy my tape, so I'm not going to bother copying it. That's fine. That's all fine. Okay. All right. All right, all of that stays the same. All of that is fine. All of it is fine. Now I rip all of this out. So if I haven't been through this, then I need to notify it to explore a given okay, source. Tell it to explore a certain exit. Okay. Right. So actually, that doesn't need to be a pointer. That can just be regular. Source gesture. Okay. Okay, that's all fine. That's all fine. This now is a list of locations. This is a location. that I'm currently headed for. Okay, it's all fine. That's all fine. Source dest location. This is a maze. And it outputs a list of direction. Okay. How many people have solved today out of curiosity? Less than 1,000. Okay, I'm not doing too badly then. I feel okay so far then. Because I've been finishing roughly in the 600s, so this is fine. Okay. How do I tell myself to go? I need to be able to perform a move into an unknown location. That means that has to be an exit that I'm exploring into. But I don't necessarily... Do I know... Yeah, it's fine. Okay. That seems fine. Okay. work list. Yeah, okay, that feels fine. That's a list of lokes to strings, yep. So that's not actually strings, it's directions. Okay, what did I mess up here? There's probably going to be a ton that I broke. To dest. Okay, that's fine. That needs. Okay, this loke is now dead. Replace with that. Yeah, that's fine. Okay, now I explicitly initialize the room, and I will populate its items and contents and so forth. That should work. Okay, 162. Outbound. Outbound is now a list of directions. Okay. Now, this will get updated automatically. Yeah, that should get updated automatically. That's fine. Room. Okay. It's a list of exits I want to explore now. Okay, 125. Okay, line 200. The joys of refactoring. Chord doesn't exist anymore. I just have a location. This is now a maze. This is the keyword nil. This is line 209. If I'm pathing somewhere, and I'm trying to get to an exit. Okay, we are pathing there. If we do get to the source, still need to... How do I know when I've arrived there? Okay, we can end set the queue's target when we arrive where we need to. Okay. Let's... There we go. That should handle it. Next direction returns a direction. Getting there, 178. Send a stringified version of that. Instead of dest, it's target. So this is now no longer a location. This is an exit. I've already explored through that exit. Then okay. That should never happen, but just to check. That should be assigned. Should be dereferenced. Shortest should be a direction. All of these things should be a direction. The choice of refactoring. Okay. This is now that, I think. And 261. What's wrong with that? Loc and exit are mismatched. Okay. How do we handle this? This shouldn't look like this, but that's fine. Okay. There we go. Better. So now we're back to where we were before, except for we have a better data structure. New exit. Okay, let's try that. Whole breach to end known with direction north. Yeah, that's correct. Now we're panicking at line 248. Okay, so that means that I'm passing an empty work list. My work list starts exploring my source node. Let's check each exit. Okay. Also need to check what my last executed instruction was, because if I do explore a new room, I want to be prepared to populate the room as soon as I learn its name. Okay. Meanwhile, line 248 called from line 238. Food is here. Called from line 238. This should just print my work list. And I also want to print here So a map right now says, that's my problem. None of the exits are populated. Okay. It's easy enough. So I see the problem. This is my problem. When I notify that there is a new room, I also need to add the exit. 9, pass in rooms. Okay. I'm seg faulting at line 257. If I already have a path for it. Okay. I need to take off a bracket there. Hello, JK. Okay, that seems more like it. Still be referencing at line 265. Oh, I see my problem. If I don't know where a door leads, I cannot explore it. That's fine. Because if I get here, then I take care of shoring up that last step. Okay, I believe that. 250 now is panicking. Okay, so we're evaluating both north, south, and west. Oh, but if I start in the... Yeah, okay, this is just the case of... Okay, this just needs this case. Okay. Yeah, then I can just... Okay. Okay. Now it's gone wrong. Adding new exit from navigation to east and south. Huh. Oh. I see the problem. It's here. And that actually lets me shortcut all of this. Let's not corrupt my cache in case I need it. Let's just do that. Okay. Yeah, that's fine. W. Okay, that should do it. Now I don't need to do that. Yeah, that's fine. Okay. I'm A51. Okay, did I... I don't actually know where I'm trying to go to. Oh, it's because I didn't add the reciprocal paths. Okay, now I need to add the reciprocal paths. Great. So okay. All right. So we need to prime this and say, hey, by the way, I just arrived. Now I need to find the correct exit. Then need to populate this. Let me just check that I'm doing this correctly. Just make sure I'm not doing a direct comparison. That's my worry. Okay, if destination is not nil, yeah, that's fine. I believe that. Okay. Good. Where was I here? Populating back references. And then finally set rows to nil again. fine. So I need a function that will invert this. That needs to know what its source is. Okay. Actually, I know what my arrived at is. No, I don't. Okay. So the source of it is, and then okay, something like that. Okay. Oh, why can that not be used? Oh, I see. Okay. And 197. That's fine. Oh. Like that. Should do it. All right. So we can now navigate most of it. The fuel cell, hell of all the items. Why am I now panicking? I know my adding new exit works. Let me just make sure I'm not accidentally adding new exits to places that I shouldn't. Oh, I'm repeatedly adding new exits for hole breach. Why am I repeatedly adding new exits for hole breach? to work. Okay, that's my problem now. Let's check this. Move, the move function. Move function. Okay. Why is the DST not updating? Okay, that should be updating this. Oh. Let's try that. Yeah, that should work. No, I'm still repeatedly adding the... Okay, let's print these. All right. Okay, so I should have updated hole breach. Yes, the hole breach should have been updated, but for some reason, hole breach is not being updated properly. Really curious why this is not the case. Why that is not getting updated. Like, I'm happy to just pointer type and paper over it, but I'd rather not. Yeah, hole breach points to hole breach no, hole breach no. Hole breach west. Oh. Actually... Okay, so let's see this. What's happening here? Let's reset it. Oops. Okay, so north should be populated, and it is. We go backwards. I think that there is a new exit there. We know exactly where that goes. Wait, that doesn't even make sense anymore. for each direction outbound. Just see what's going on here. So it's either this case or try that. Yeah, no, so thinks we couldn't move that direction for all of them. Is there any requested to move unexplored direction? Yeah, that's a natural process in our search. So that's fine. So why? Something is really egregiously wrong here. Okay, so oh, I see my problem. I understand exactly what I did, and I'm mad. I'm super mad at myself. Take that away. Take this away. I know exactly what I did wrong. Okay. Good. So here's my problem. My problem is this. This, in fact, already has a sensible value. There's no reason to update it. There we go. There we go. That's much better. Yeah. Okay, now the problem is just that I'm repeatedly adding the same exit. So that's fixable. In fact, this is just okay. Yeah, now I'm really, really, really wishing this were a... You know what? I can either have wishful thinking, or I can index it smartly. So let's index this smartly now, now that I know more of what I want. Yeah, I think this is much cleaner. Okay. do it. Okay. Now that makes this easier. In fact, I just need why do I sign myself up for the things like this? Okay. Okay. That's done. Okay, that's good. From instantiating a new room. Do that. We need to do that. Okay. If we're deciding whether to go to this place, okay, that should do it. Let's see whether it compiles. 21. Oh, that's just direction. 137, 189. Okay, that makes sense. And 189. That's going to be nil, that's fine. And then 225. Oh, that's simple enough. If I notify there's a new room existing, does notify room get called at all anymore? Yep, does. Okay. Great. Okay, that feels better now. Okay, adding 3 new exits, that's correct. Take the candy cane and then go back south. I've already queued those for exploration. Now you go northwest, take the mutex. Chocolate fountain west, go east. So I need to know which direction I'm trying to go now. Don't need to know about adding a new exit anymore. Okay, let's try praying that out. This is a print F. Okay. So I'm pathing to Whole Breach West. Decide to go north. I don't need to do evaluating move to. Okay, so let's try that. Okay, so let's check my exploration now. Pathing north, I successfully get there. Pathing to Whole Breach South. I go through Whole Breach, and then I go Whole Breach South. I get there. I've recorded it. Okay, now pathing to Whole Breach West. Okay, I get to the Hot Chocolate Fountain. I take the mutex, and then I path to navigation east. So the path to navigation east. Do I know how to get there? Where is navigation? Navigation was here, so I should definitely know how to get there. So Hot Chocolate Fountain should know to go east. Why am I unable to find the path? 9274. Print my work list. So I considered the Hot Chocolate Fountain, considered Whole Breach, but I did not consider navigation. Why did I not consider navigation? Okay, I'm not sure why navigation was never added. So let's check the rooms first of all. Does navigation appear there at all? Yes, navigation is on the map. And navigation should be located north of Whole Breach. So if I go from Whole Breach and I go north, what happens? I go from Whole Breach and I go north, I should indeed be able to get to... Oh, that's my problem. Okay. Yeah, I was justifiably worried that using that pointer would backfire. Let's do this way instead. Let's just do it this way. Yeah, this is the problem. It's dereferencing ex.source, so that was just a bad shared pointer, which I have now helpfully averted. Now I just need, now this is just is ML resolved. Not resolved, return nil. Otherwise, return ML dest. Done. Oh, M L Dest. Okay. Isn't this going to set me up for the same problem? That's what I worry about. Fine. We'll do it this way. Grr. This is a little frustrated. Okay, that should do it. Oh. That's fine. That no longer needs the dereference, which is great. 188. And finally, 286 doesn't need that pointer dereference. Which is fantastic. Okay, now this should work. There we go. I don't want to take the photons, so when I don't want to take the photons, okay, now I have a mechanism of encoding that. This should actually force the skip. Also, that's not needed anymore. Okay, so let's run it. So we've taken all of these items. Yay, we found most of the things. Great. Oh, I don't need having to anymore. Goodbye. Yep, that does exactly what we think it does. So why does it stall when I tell it not to take the photons? It knows not to take the photons. That's why it paused for my input. But also doesn't do anything else yet. Oh, I see. That should be a for loop. And then okay. That should do that. Okay, and that should break out of the for loop. Okay. Oops. That's a break still, and this is a continue parse. Okay. All right. Length of outbound, yep. Whoa. Take candy cane over and over. Oh, whoops. We didn't. Yeah. Continue parse. That still needs to do this. Ah, no. Do not end justify. Okay, that's. I see my problem here. Okay. Okay. I cannot take the giant electromagnet because that prevents me from moving. Great. Molten lava. Goodbye, molten lava. Oh, I should not take the escape pod. Okay. Haha. Great. I'm going to commit my answer so far because I like it. Add progress on 25A. Tap my security key. And okay. Okay, so okay, great. So if I get to the security checkpoint, so now I need to go back and read the puzzle description. Puzzle description says, in the ship are lighter than the detected value and you're rejected back to the checkpoint. Taken every item that I could find. Oh, I see. I need to not go through the if I see the security checkpoint, I need to continue exploring until I've found every other room and taken every other object. Okay. It's fine. Okay. Okay, so for now, we need to treat this as not safe. So how do I treat that as not safe? I guess the best way of treating it as not safe is this way. I get asked to queue don't mark it as explorable for now. Okay. And I can safely use a defer here. Rooms. Oh, I actually have that. Okay. Okay. Save that off for now. So now there's nothing to explore. Did I pass picking up items that I should have picked up? Giant electromagnet, photons, molten lava, dehydrated water. Like, did I pick up anything that I shouldn't have that made myself lighter than I needed to be? I took the coin, took the cake. Let's list my items. Okay, so let's actually. So I get to dance. Then I don't carry out that command. And I instead fall back to I'm going to not do that then, and I'm instead going to hand over to manual control for now. Nothing left to explore. 200. Okay. Oh. Okay. These things all seem useful. Whoa. It really doesn't like that. Oh, because I stopped parsing the input, that's why. Okay. Stories in this ship are lighter than the detected value. Got it. So I need to drop some items. Okay, so if I get the you are ejected, I need to randomly drop some items. So it says actually let's let's just leave this to humans to do at this point, and I'll automate it later. So I'm pretty sure I have all the items. I just failed to read properly. Okay. Okay, so that works correctly. Oh, that's very funny. Items in your inventory. Items on your inventory versus items here. Need to not act on that. Okay. Fine. Oh, like that. What? Why does it think I didn't pick? Oh, I didn't pick anything up because it says items here, colon. Why did I not pick it up? Items. Why did that not work? It says items here, colon. Oh. Because that includes the grumble, grumble, grumble. I hate Go sometimes. There we go. Okay. Let's drop the heaviest sounding thing. Oh, it took everything automatically. Layer than detected. Okay, so now I know what to automate. So I need to try all the permutations of this now because I get no signals about how much is heavier than what. So I need to actually wait. There's a way to bisect this. Okay. Can I drop all? Okay. So now I have too many things. Yeah, but this is not going to help me because it could be arbitrary values, and if I get the wrong one, it's just not going to tell me. I think the correct sequence is take items and drop them until we okay. Okay, so every time we get bounced back to the room, we know. So next is always west. And then we just try a varying combination of items. So we have all items. Okay. Okay, great. So that way. Now I did a thing that would conveniently permute these all. So let's steal that. Okay. Okay, so I have a bunch of list indices, so that's fine. Okay. Let's figure out how to do this. It's only 8 items. 8 factorial is not that bad. I'm just going to power through it because it's almost 3 a.m. and I'm feeling about done. Okay. First reach. Here, how do I keep track of my progress? I guess I need to try. Okay. All right. Gets a list. How do I approach this? Instead of running a permute, I want to run a choose. How do I do a choose? So in order to get a combinatorics choose function to enumerate them, what? One is to visit all the binary numbers less than to the n. Track k index numbers of the element selected. Repeatedly, I don't understand this. It's not making any sense to me right now. Okay. Let's see this. First of all, we need to do a string sort. So in Golang, the sort package. Just want to make extra sure that I evaluate these in the same order as usual. Okay. Actually, I should do that before I do this. Okay. Have a variable called all items. Yes. Good. Okay. God, I'm going to have to figure out what to do after I get past that room, too. What if there's multiple rooms that are like that? That would be dreadful. What does the problem description say? Alters display the same amount. You might be able to reach the correct way by carrying items. Okay, that's fine. That's the main airlock. That's fine. Okay. That should be fine. And I need to read from the channel to consume this next output because I otherwise know it's going to be a disaster. I need to consume range lines. Okay. It says prints out a message saying you dropped the fuel cell and then asks for the next command. Oops, not day 27. Okay. Let's try that. That doesn't go in there. This goes in here. Okay. And then afterwards, we'll mark checkpoint try plus. Okay. All right. So it follows that we do a straightforward take every permutation. Yeah, I feel okay about this. It should be fine. Okay. All right. So we know using all of them doesn't work. So I think my plan is. The problem is I don't want to pick up the duplicates. I just want the combinations. Okay. How do I do this? I'm going to have to look up how to do combinatorics on Wikipedia. In the power sets, how does one make power sets? Okay, thanks. I hate it. How do I do a power set? Oh. Yeah, I guess it's technically true. Okay, we'll try it. Yeah, it's technically true. Okay, fine. All right, fine. I understand what I have to do. I'm not very happy with it, but I hate it. God, my family's going to be mad at me for being up until 3 a.m., but you know, this is how it goes. Oh my God, I've been at this like 3.5 hours. Okay. If I visible, then all right, let's just do some bit shifting. That should work, should not. Let's print F. Oh. All right, let's try that. That's a string, that should be fine. Non-integer slice index, oh. Right, because that's just this. Okay, fine. Why does it think I don't have that item? I get ejected. Where am I now? Oh, I found the right set of items. And then it finally worked. Wait, why didn't it pick up all of the items? Did I read an insufficient number of things? Let's try this. Now I'm deadlocked. Should this not pick everything else? Don't know what to do with the list outside of parse mode. Don't have that item. Okay. So that was actually correct before. Let's try that again. Why does it think that I don't have that item? You're ejected back to the checkpoint. Items here needs to happen first. Oh, I see. Shouldn't I have picked everything up first? That should have happened first. Doobie-doobie-doo. Okay, getting close. I'm not sure why it's deadlocking. Okay. I get here. I dropped all of my items. I get ejected east. Try to drop coin, but not cake. Oh, interesting. Let's try keeping a minimal drop list instead of a maximal drop list. Let's do it that way. Okay, so now I'm deadlocking. Why am I deadlocking? Take candy cane, take cake, drop cake. So I send the drop cake command. I see it's almost like there's supposed to be like 4 new lines here. I'm pretty sure this is incorrect. Let's try that. Whoa, it's repeatedly, whoa. Uh-oh, that was not intended. 1 second. Let me get that back to where it was before. Stand by. Oof. It shows how tired I'm getting. Okay, hopefully y'all can still see this. Oops. So the thing it was doing was, now it's repeatedly instructing it to drop cake. Wait a second. I know what that problem is. That problem is so this I printed. This I printed. So I need to read 1, 2, 3. One, 2, 3, 4 lines. Yeah, I think that's correct. Was it repeatedly saying drop cake, drop cake, drop cake? Yeah, okay, so it's repeatedly having me drop the same item. It's very strange. Let's just try. I'm really curious. Am I being instructed to drop here? Oh God, it's telling me to drop cake, cake. Why is it telling me to drop cake, cake? Oh, I see. I see. Oh, now I feel silly. Okay. There we go. Now we won't add it multiple times. Okay. There we go. Problem solved. Yay! Thank goodness. Rank 890. Wow, that's surprising. Continue to part 2. And I can align the warp drive. And I win! Thank fuck. Sorry, Larry NY. You caught me right as I finished it. But yeah. So Santa, we have found Santa, and everything is well with Santa. And now we can look at our advent calendar. Ooh, look at those stars. Pretty. I think that's tracing the journey that I took. Yeah, it is. Awesome. Yay. Yep. Starts at Earth, goes there. Yeah. Okay, that's super pretty. I like that. Okay. Well, I'm pretty happy with that. Finished in the top couple hundred. I'm quite chuffed with that, honestly. Great. Okay, let's tidy this up, shall we? Cool. So how do we need to tidy this up? So now I'm going to set it to verbose mode. Okay. So unless it has a numerical 6-digit code, we're not going to print it out. Okay. So now that I have this working, let's do that. And let's do that. And then finally, if it starts with a quotation mark, then we know it's good. So this condition doesn't apply. No, he says he starts with a quote. And that happens even if we're not running in debug mode. So, oh, that doesn't need an escape sequence. 978. Oh, floor, that goes away. Now we're getting into somewhere we can't leave. That sucks. Oh. Why does it think that I got into somewhere that I can't leave if I don't print the debug output? That's so surprising. Ah, there we go. There, I think that works now. Yep. Which makes sense because we can't actually leave Santa's lair once we locate it. In fact, what's Santa's message? A loud robotic voice. So if it says a loud robotic voice, oh, but we're into pressure sensitive floor. Okay. So at that point, we're not. So that's actually working as intended. Excellent. Okay, that actually generates a clean result now. I'm pretty happy with that. Let's just, because I like doing things like this. How many inputs did we make? And I need to define inputs up here. Okay. Now that should work. What? It's not good. There we go. So sometimes it's doing a weird deadlocky thing. I cannot really be bothered to fix it. So I'll just default debug to true, and if anyone has some problems with it, then, you know, they can... Oh, I see the problem. Problem here is... That's my problem. Let's see. feel it. Not more dependable. Okay. What if I have an abnormal exit? What happens then? I think I eventually close the output when I finish. Let's just check that. Yep, I close output, so that should always terminate. Good. Okay. Okay, 25 a solution. All right, so I think that is it for me for Advent of Code 2019. Thank you all for watching and coming along this journey. If you want my code, it's at github.com/LesLeGray /Advent of Code. And you can also see my YouTube channel if you want to watch the backlogs. So thanks. Have a good night.